to 64. We've done these problems before. I had 12 and 52 was the only other pair. 13 and 46 didn't add up. Were the only two numbers that even added up to 64. Aside from, I got a lot of crazy decimals from you guys on this test. Like 19.75 and 44.25, or 18.5 and 45.5. Any of these problems you did with Miss Woodruff, Susie was 7 and Barbara was 14. Right? There were no answers that came up to Susie was 14.6. First flag that something is out of kilter. Second thing is, of the decimals I got numbers like 23.5 and 50.5. 23 and 50 is 73. So after they calculate the two values, they don't even add up to 64. Those are clues to send you back to try and find whatever error was causing that to happen. 2 and 3 were inverse variation problems. Before Miss Woodruff came, back when we were talking with linear equations in Chapter 3, before quadratics, one of the things we discussed was direct variation. Direct variation is y equals kx. We might recognize that more as y equals mx plus 0. Because the direct variation problem was a linear equation that went through the origin. So if I wanted to get the k or the m by itself, m or k equals y over x. That's where the slope comes from, guys. That's the direct variation. Then we have this inverse variation. That's not y equals kx, but it was given to us as y equals k over x. And what this was about was finding that k value. So for some reason, a ginormous number of people in the population read this as if a 2-pound board breaks with 24 pounds of pressure, a 5-pound board breaks with 60 pounds of pressure. That's not true. That's direct variation. Inverse variation, after we find the k value, in this case of 48, means that the longer the board, the less the pressure required to break it. So, FL equals K. And we find out that the K value is 48. To answer the question, how many pounds of force do I need to multiply by a 5-pound board to equal my 48 is 48 over 5, which is 9.6, 9 3/5. Similarly, for number 3, the only difference here between y varies inversely with x, in this case it wasn't x, it was the square root of x. So I tried being as gentle as possible because there were some people that did find the k value. If you got problem 2 right and you told me you had a k value of 96, that meant that you forgot to read it as the square root of 16. When they tell you that x equals 16, y varies inversely with the square root of x. So if you input x equals 16, the square root of x is 4. So for problem 3, the k value is 24. Then they ask us, what is y when x equals 4? The square root of 4 is 2. 2 goes into 24 12 times. So answer for number 3 is 12. All problems are worth 10 points. Number 4, we were expecting to see in the system chapter, either here's several equations, graph them, or in this case, here's a graph, identify it. First thing, guys, you got to recognize that's a quadrilateral bounded by 4 sides, which means there are 4 lines, there's 4 equations. So for the easy ones, y is less than or equal to 6 and x is less than or equal to 0, those are worth 1 point each. 5 points came from line 2, the dotted line with the negative slope, because as promised, it was not going to be an integer y-intercept. So after calculating the slope of negative 9 over 4, we plug that back in to find the y-intercept is negative 7 over 4. That one inequality, provided you told me y is greater than negative 9 over 4x minus 7 over 4, was worth 5 points. And line 3, the point there in quadrant 3 is negative 3 comma negative 2. And even if you didn't see that small negative sign, guys, there's a picture of this graph right here. And what caused people to lose points for that, what I called line 3, was they calculated the slope at 1/5. Because they thought that the 2 in this ordered pair here was negative 3 comma positive 2. So they got negative 1 over 5 instead of 1. But you needed to look at that line. There's no way that that slope can be up 1 over 5, up 1 over 5. That's just the y equals x line that goes through y equals 1. So that inequality, 3 points for y is greater than x plus 1. Yeah. The next two problems were really all of the problems were valued, but in a chapter on systems, problems 5 and 6 really kind of summed up what was going on here. And what I thought was a fairly easy 20 points turned out for a lot of people to be just that, but for a lot of people, not the case. When we rewrite that first equation, x squared equals 4 minus y, it's a parabola. It's a U-shaped down parabola with a y-intercept or vertex at 4. It's a standard over 1, down 1, over 1, down 3, over 1, down 1, 3, 5 pattern. And that parabola intersects y equals x plus 2. Doesn't get much easier than that for the linear equation. So the 10 points for that simple graph came from an accurate parabola of 6 points, the line 3 points, and the fact that you recognize that the line intersects the graph at those 2 points. I gave a point for the coordinates. The only exception I made there was if you happen to be one of the students that solved it algebraically correctly, I just drew arrows up because everything matched. That was a crazy thing. That some people drew wonderful graphs that their math didn't match, and some people drew such sloppy parabolas that there was no way in heck that you're going to be able to determine where the line crossed the parabola because the parabola was just like wildly drawn. Right? How do we get an accurate intersection if we don't have an accurate graph? So, finishing up this problem here algebraically, I love elimination. I think you guys know that. When there's an option to do elimination, I'm going to. But this problem, when y equals x plus 2, anywhere I see y for the first equation, I'm going to replace that with x plus 2. That's exactly what I did. And I wind up with a quadratic, x squared plus x minus 2 equals 0. That means that we have two x values. And the x values are negative 2 and positive 1. But we're not done there. Some people that even set this up stopped here. What does x equals negative 2 and positive 1 mean to that system? Those are just the x values of coordinates. So you needed to take each one of these x's and plug it back into the equation to find out what its corresponding y value was. So for problem 10, 6 points came from finding the x values, and 2 points each for showing me where the y values came from. So the points of intersection here, -2, 0, and 1, 3. Okay? You good there, Eric? And this next one kind of threw me for a loop too, because a lot of people did very well with it, and a lot of people did absolutely miserable. Now, I know that, because I went back over when I talked fairly extensively with Ms. Woodruff about this, because she taught the majority of this chapter. So we discussed, in fact, the majority of this test was hers. I made a couple modifications, actually shortened it a little, and we definitely discussed that we needed to include a system that had a circle in it. And that was one of the times she spent a good amount of time talking about x squared plus y squared equals r squared. It's the equation of a circle. In this chapter of systems, one of the things that we didn't touch was ovals. All we talked about was circles. Right? We didn't talk about ellipses or hyperbolas. There are several equations that we didn't use in this chapter on purpose, meaning that we wanted to focus on lines and parabolas and circles and cubic. So x squared plus y squared equals 3 and y equals 1 minus x squared. The way I gave the 20 points for 6a and 6b was I looked at what you said about 6b. And we talked about this question here because notice it didn't specifically say to graph it, did it? Boy, oh boy, would so many people gotten more points had they graphed it. But we intentionally left it open because many students did graph it, and the ones that did graph it tended to get the whole thing right. But what does a system look like graphically, and what does its solution mean? What we have here is a downward opening, or a downward U-shaped down parabola with a vertex at +1 that intersects with a circle centered at the origin with a radius of the square root of 3. And since I know the square root of 4 is 2, I know that this circle has a radius less than 2. So I drew the circle, I drew the parabola, and then what I needed to do was then go back up top to find out what those green values were. So given those two equations, once again, your elimination-loving teacher says y equals 1 minus x squared. Anywhere I see y in the first equation, I'm going to replace it with 1 minus x squared. Question? Yeah. Really, during this exciting problem? Go ahead. So I did. And what happens when you square a quadratic, x squared squared becomes x to the fourth. We know linear equations, 1 solution. Quadratic equations, 2 solutions. Cubic equations, 3 solutions. Quartic equations, 4 solutions. So I wind up with an x to the 4th power. But that was one of the problems that we learned how to factor it. Let x to the 4th equal x squared. Go ahead and play with it and then substitute back in. You'll find out that x squared minus 2 times x squared plus 1 equals 0. Using the zero product property, we can add 2 to both sides and take the square root and get plus or minus square root of 2. The problem is when we subtract 1, x squared equals -1, we take the square root of both sides, and that's what we're discussing right now, is imaginary numbers. That meant of the 4 solutions, 2 of them were real, and 2 of them were imaginary. Now, once we find out that x equals plus or minus square root of 2, what do we need to do? If x equals positive square root of 2, you need to plug it back into one of the equations and find out what its y value is.
I'm just a little confused because we never ever did a system of equations with a circle in class.
Oh yeah, you did.
No.
I saw him on the notes.
I could be wrong though, so.
Did or didn't you discuss circles in a fair amount of detail? Well, dude, a circle, the vertex here is at the origin. The circles don't get much easier than that. But I know for certain he talked about x squared plus y squared equals r squared.
We also talked about that.
Obviously, something went wrong.
But like the whole question's like asking what it's supposed to look like, and if we haven't explicitly talked about like, you know what I mean?
You have.
Like I was just.
Even if you, all right, so that's what I was prepared. Even if you wanted to argue that, it doesn't matter because independently, you know what a circle looks like. Independently, you know what a parabola looks like. And this is an honors algebra 2 class.
I know.
That means nothing to me. It was hard to me.
But you did learn circles. Yes, you did.
But not like that. Like you're right.
What do you mean not like how? It's the same process. That was the whole point. Is it doesn't matter what the shape of the equations are. We solve systems the way we solve systems.
Well, obviously something's wrong if someone.
We.
No,
Let me.
no. I mean, you can come see me if you want. Combined classes, there was 12 people that got scores over 90.
I mean, maybe.
And there was a lot of scores. And there was lots of scores in the high 80s. Yeah, the work, it's there. Out of 60 students,
what percentage of the class got that question correct?
That's. I
raise
don't
your
think.
hand if you
I
want
don't
to.
think that's
It's up
what
to you
matters.
guys to discuss that. A lot of people got
So
this.
there's a
I don't
problem
think-
there. Most of the class got it wrong.
I
That
don't
means if
think-
we didn't go over it, we need more help to go over it, doesn't it?
I just don't think we did enough of that. Like, we knew the equation for circles. We knew roughly how to graph one. We never.
Do you know how to solve it?
Actually, I don't.
We never.
Didn't I solve this the same way I solved number 5 on the previous page? Was I use substitution to eliminate one of the variables? These are just two variable, two equation systems.
No, we're getting like imaginary solutions there, and we didn't even know what those were.
Yeah.
Like,
Also,
this
It doesn't matter what they are.
It's just a really complicated problem.
I didn't know you
None
grabbed
of
that
us were
circle. I'm not
prepared
gonna lie. I don't know you did.
I don't. But that's. It's fine. Like it is what it is.
And that was, as I said, this is one of the things that we didn't talk about. Didn't require you to graph it, offered you to graph it. Had you taken advantage of it, you might have gotten further in the problem.
You said that everyone that actually graphed it got it. Like,
How do you even grab that? Like, honestly.
Also, it just
How much clearer can I make the picture? I got 2 colors going for
I
you.
don't even know where you got, like, I don't understand where you got the square root of 3. Like,
I will go back over the notes and I will get the particular slides for you because she sent me all of the handouts, all of the smart notebook slides of things that you covered in class.
okay, that's
Some
not
days
gonna
I
help
was
it.
in
Might
there,
need
some
extra
days
help.
I
Some
wasn't.
people need extra help in things, okay? Like, that's not gonna help it.
What's not going to help?
Like, you just mean like we went over it. It's like, okay, I understand we went over it, but if I need extra help on something, then I'm gonna look for that.
Then who needs
help.
to bring that to somebody's attention before a test?
How am I supposed to know it's supposed to be on the test? I didn't grade the test.
we also went over circles like a month and a half ago, which didn't. It felt like it wasn't even a part of this test anymore. Like
Okay,
we did no review on it before. Like circles felt completely irrelevant to this test, and then surprise, we're supposed to.
how could circles feel irrelevant to this test when we are dealing with a chapter that's solving systems of nonlinear equations?
because we never, I get what you're saying, but
We
we
just
never
didn't- we
talked
didn't do
about
enough
circles in
circles.
this context. You know what I mean? And so then
I will find the exact problems that were talked about in class and assigned for
But you
homework.
weren't in the class.
and we'll take it
You
from
weren't
there.
in the class when this was the teaching thing.
What's that? Can you talk to me?
I love this class. This is my favorite class.
You can't get pissed at me under your breath and then I'm trying to have a conversation to talk about this.
It's-
I think maybe Miss Woodruff just taught it in a different way than you would have. You know what I mean?
From our perspective, in the way that I can put this most understandably, it's just really frustrating to have a problem like that show up on the test because if I'm speaking for most of us here, I don't feel like a lot of us were really prepared for a problem
Not
like
at all.
I'll look into that and I apologize. Nobody said, all right, that's fine. All right, next one was our 3 variable system. And the answers were 3 over 14 for x, 4 over 7 for y, and negative 31 over 14 for z. So I think the vast majority, except for those that really took a lot of paper and did it a more complicated way, saw something's going on with the z's. If I combine the first and second equations, I can get an equation that has no z in it. If I take the second and third equations, I can easily combine those and get a new equation that has no z in it. That was what most people did. And from there, solve for either x or y. I chose to eliminate the y's and find out that x equals 12 over 56 or 3 over 14. Plugging that back into one of the two equations that I just formed, found out that y was equal to 4 over 7. Now that I know x and y, I can go back to one of my very first three equations, plug in x and y, and find z. A quick check of an equation or two verifies that the answers were correct. There were a multitude of different ways of solving it. So again, it's not my way or the highway, but those are the solutions if you chose to get there a little different way. I do try to pick the easiest route possible. Doesn't always happen. All right, and here we needed a little bit of detail. Explain in general terms how you solve this system. So I needed people to tell me what equations that we were dealing with, what variables were eliminated. So by combining equations 1 and 2 and 2 and 3, the z variable was eliminated, leaving two equations with two variables, x and y. Using elimination on the y variable, found x. Then I used x to find y. Having found x and y, plugged that back into one of the original equations to find z. Done. Try to give as many points there, but a lot of people were solve this, or if I even saw the word eliminate or solve for a variable, didn't tell me what variable you were solving for, or if you used elimination or substitution to get there, what we were doing with the equations. So again, that's part of the communicating. Graphically speaking, we have a point because each one of these equations in x, y, and z is a plane in 3 space. And everybody take a look up here. When two planes intersect, what's the result when two planes intersect? A line. When a third plane comes through and intersects that, we change our line to a unique point. That point was 3 over 14 in the positive x direction, 4 over 7, or a little bit more of 1/2 in the positive y direction, and z was down a little bit further than -2. So what happens is that point right there is the point of intersection where all 3 planes intersect each other. Long-winded, short-winded. Each equation represents a plane. Create 3 planes in the x, y, z, in x, y, and z. The place where the 3 planes intersect is the point or coordinate that is the solution. Blah, blah, blah. Much easier in the cloud to the left. 3 equations make 3 planes. 3 planes intersect at a point because it's a 2-part question. Explain what each of the equations looks like graphically and what the solution means. Graphically, each equation is a plane. What the solution means is the unique point where those 3 planes intersect. All right, so aside from number 6, which I am going to take a look at again and talk about it, make sure everything was added up correctly on the paper. And Away we go.
Can you go back to the report?
Sure. Number 4. Inequality. Two lines.
Like, math should not be a guess. Math should be
That horizontal line.
from these problems. It seems like pretty much a fucking guessing game. You're getting 3 over 14 or negative 31 over 14 is your fucking answer. It's like,
Oh, line 2. Slope.
maybe how about like 9,
Same.
8?
These are the parts
2.
that make up
Those are variables. Those make sense. Oh, you can graph those.
This is line.
How the fuck do I graph negative 31 over fucking 14?
Line 1 is this. Line 2
I'm trying to remember. So I
is this.
I squared it.
Line 3 is that. And line 4 is.
Are you already positive or are you
How is it positive? Where is it positive?
the first two? These actually.
I don't know.
What is like here?
I
is
6 plus 1. Well, Adam, where are you starting from? Okay, positive.
0. We found the slope and the y-intercept.
So I,
There's like a pattern.
I know I and the negative 1.
Probably and
No.
If you like I to 8, or if you
Like,
this is simply y equals y.
pretty much just do this.
What's the order again? It's negative.
I have a really good way of doing it.
I negative 1.
For the test, let's say you get I to the 1,200. You pretty much said he's going there.
So that
The last digit is the so what's I times 4?
there's no way that
What
this
if I
line
give
is
you
5
5
That's a slope of
these
1
two
over
numbers?
1.
And
So
the
when you
last,
calculate the slope of 1 over negative 1 over 5,
it's
what you're saying is of 1 over 5.
and then you just do the math.
Wait, so what's I? What's wonderful? What's it like? All I need to know is that I know.
So I first is just
Second.
And that's what I want to do is create a very small negative quadrant. X's are negative, Y's are negative.
yeah.
Oh, that's like positive and negative.
Test where you guys take
So I so they can actually
I won.
3x is negative,
I
5.
won.
And even if you did, you gotta look at this.
It's like I negative 1, negative 5.
And we ask ourselves, is this
I
a reason?
every other one.
Yeah.
Up
And
1
there's
over
negative.
5, up 1 over 5. It's not
And listen,
right?
if it's 10, that means it's if it's 10, then it means it's
So
negative
because-
negative 1, right?
Now, what did you get here? 5, 6, and I didn't give you a point for that. Because the wrong slope was the wrong y-intercept.
Yeah,
There's no equality.
Little I dot.
it's not like
So, 1 plus 5 is 6.
I did a 30.
Okay, I'd like to take a look at yesterday's homework. Yeah, question, come out and see me.
But I would do it wrong. radiator. Wait, I don't know.
Other problem with gravity, though, is the fact that
Yeah, no, that doesn't make sense. Never mind.
Well, you can say
so
28.
if it solves the system credit down here and count the points, then I would have just drawn it. But when we're looking at down here, how can X be plus or minus 2? There's only one. I mean,
Did you we got a 77.
everyone basically
well, when you're going to solve it graphically, you need to know.
Obviously, we got to show this I quiz.
When you get answers like negative 31 over 14.
No.
So you're the point. This is actually nice gravel.
Don't do what I told you.
Slow.
I know you're talking. I didn't know that first.
But
You pretty much just divide that number.
because you didn't get this right.
See if it goes here. It doesn't bump down what's happening. I don't know.
The closest one is that's the one, right?
So 80? 80 is
So it is 4. Yeah, 80 is 4. So if it's like 83, or
Or let's say it's like 42. It would be hard to say.
yeah. So like looks like 40 goes into that one, so then you go 1, 2, 3.
We got
Dude, what do we have to read besides the?
Isn't that really long history?
Yeah, that's it, right?
Are the textbook pages like not the pictures, but like what we have
I'm going to post this because we're not going to get to it. Okay, guys, take a peek here. I'd like to go through this with you guys. So, as fast as comfortable for you. I will also post this to Edline so you guys will have it to look at. So I'll just scroll through and then wait to see if there are any questions. I do once again have a favor of you guys. I know that many times when I do a solution, I show most, if not all, steps. I cannot emphasize to you guys the amount of points lost when you try and do too much at once. You do it as mental math and you do 3 steps in your head and a negative number turns positive. I get a reciprocal instead of the number you meant to give me. Guys, you're killing your own selves. So I'm not saying that you need to show every single step all of the time, but if you're one that's tired of losing a point here and a point there and a point there, because you got the big picture and you keep losing little points off of small stuff, that sloppiness ends if you include an extra step or 2 of work. And that's really going to hold true here, where we're dealing with I squared equals -1, so we got signs to watch out for. We got exponents that we're sharing inside the parenthesis. Sometimes we're adding the exponents, sometimes we're multiplying the exponents. Please. Second thing is the same thing I told a number of students in the last class. It's interesting when I look at many students' tests. They will go through 1 pencil and 3 pencils erasers. And that's fine. But those same students, if I ask you to open up your homework, how many of those students that have gone through an awful lot of erasing on their test have applied that much effort to the homework questions? And the answer is probably not enough. And another thing that I said that leads back to there is not enough time when we're taking a test for you to figure out how things work. Not denying that you guys are not a bright bunch of students. You are. Otherwise, you wouldn't be here. But I'm saying that there's stuff that you need to learn prior to coming in to take a test. And if the first time you are really genuinely concerned about an answer to a problem is because it's attached to a paper that has a grade that's worth 40% of your grade, you're missing the bigger point. And that's all I'll say about that. All right, so questions on 6 or 7? We did talk yesterday about our pattern for number 9, right? Y I to the 4th equals 1. We got that pattern and built it up, so make sure you guys are ready to answer what is I to the 27th power.
Mr. Quinn,
Yes.
I have a question. I understand the pattern and how it works and everything, but what I don't understand is how I'm supposed to figure out like I to the 200th power just by knowing that every 4 is the pattern.
So the hint I put is here at the bottom.
Oh.
That I to the 0, 4, and 8, and 12, and 16, and 20, and 24, and 28, and 32.
I can't really see that.
What's that?
I can't really see that.
Okay, what it says here is I to the 0, comma, I to the 4th, comma, I to the 8th equals 1. Here's I to the 0. I to the 1st power equals I. I to the 1st, I to the 5th, I to the 9th equals I. I squared, I to the 6th, I to the 10th, all equal negative 1.
Okay.
If we go this way, I to the 0, I to the 1, I squared, I cubed. I 4th, 5th, 6th, 7th, 8, 9, 10, 11. So I'm going to let you think about, there was an idea yesterday about dividing by 4.
Okay.
So that would probably be a great place to start. So if a number is cleanly divisible by 4, that means that we're at this point here where the answer is 1. Then based on the answer to your division problem, let's say I to the 83rd. What is I to the 80th? I to the 80th is divisible by 4, right? So I to the 80th equals 1. Now you just need to ask yourself, to get to 81st, 82nd, 83rd, where am I at in this rotation?
Okay.
And this will be posted for you
Okay.
to look at. All right, 10 and 11 conjugate questions. So any questions or comments there? 11 was interesting, especially 11A. Good quiz question there. We needed to distribute the I and then rewrite the equation or expression to negative 2 minus 7I, and the conjugate of that was negative 2 plus 7I. Questions, comments? Did it a different way? Makes sense? I didn't get it, but I get it now. Number 12, how many got a third for the probability question? After simplifying it, there were 4 real and 2 pure imaginary terms. So if you reach into a hat, what's the probability of grabbing a pure imaginary? 2 out of 6, or 1/3. But a problem like that on a quiz or a test would require you to show me how you adjusted those values. Right? We would never leave negative square root of negative 4 as a final answer. All right, we had to do some multiplying. Multiply the binomials with an imaginary term, a plus bi times a plus bi. This is a critical step because negative 9i squared is equivalent to the number 9. On the next page, what we needed to do was take a number like 9 and rewrite the number 9 as negative 9 times I squared. And that was for factoring purposes, but we'll get there in just a second. So any questions, comments on 13? All right. Number 14, good thing I had so many colors at my disposal. So this is just a review question. Again, finals are a long way off. We have many chapters to cover, including a lot of work on trig functions, identities, and properties. But count on the fact that transformations of functions is going to be one of the topics that's fairly biggie. So at minimum, and I would probably expect to see parabolas. I'm not going to have you shift cubics, I don't think. But good reason to have 4 different colors or 4 different graphs, because this is all about shifting and opening and narrowing the graph. So I will leave that up to you as did you get 4 out of 4, 2 out of 4, 1 out of 4. I have no idea what the hell this is. Okay, 15. That's exactly what I was talking about on the previous problem. Here we needed to look at positive 4 as a negative value, so we could have the difference of 2 squares. So positive 4 is the opposite of negative 4, and negative 4 can be written as 2i quantity squared, because 2 squared is 4, I squared is negative 1, so 2i squared is negative 4. Same thing for B. I don't know about you guys, but I find it easier to flip the order. So we could have done it the other way around, but visually for me, I prefer to look at 9 plus 4x squared as 4x squared plus 9. Rewrite 9 as the opposite of a negative quantity, and factor that over the complex number system. 16, some interesting questions. Some were rational and some were not. So x squared equals 25. That's going to give us answers that are real numbers, plus or minus 5. But try to take the square root of negative 36. That's where our new friends, the imaginary numbers, came in. So plus or minus 6i for B. C and D, same idea, with x squared plus 49, x squared minus 49, and how they behave. Check your answers for 17. A was negative 24, B is negative 3i, C is 3, D is negative 8. Now, I showed you guys the 2 things that you need to know about imaginary numbers. Number 1, what is the square root of negative 1? I, and I squared equals negative 1. We talked in detail that while the square root of square root of 18 is the square root of 9 times the square root of 2, may I do that with the square root of negative 18? No. That's why the imaginary numbers exist. Other than that, we are factoring and solving and multiplying and adding and answering probability questions of things that operate the same way they always have. The imaginary numbers, we solve them just like we solve real numbers. Okay? So more practice tonight. By the way, tonight's homework, which I promise will be short, we'll spend 2 days in 8.4, but that's it. That's the end of our chapter. There's only 4 sections in this chapter.
Do we have a quiz?
Before the end of the week.
What?
A quiz or a test?
So Thursday?
Renata, write a late on that one. Yeah.
See you later.
How are we supposed to have